back to another lesson with Mr. Biza. And in today's lesson, we're going to be talking about two-step equations. So let's jump into it. So before we start solving for two-step equations, the first thing I want to know is all the different parts of an equation. So here I have an equation written down, 15x plus 4 equals 60. So I want to go ahead and remember, what are all the different parts of an equation? Alright, so the different parts of our equation. Well, the first thing that I have is the 15 at the very beginning. This is called the coefficient. Coefficient is a number that is in front of a variable, oftentimes used to multiply or divide that variable. Now, a variable is a placeholder for a number. We don't know what it is yet, it's just a placeholder. Oftentimes we use letters to represent it, such as X, Y, or Z, or any other letter that we can have in our equations. And the last number is our constant. A constant is a fixed value, a number that's all on its own, and it's separated by some type of operator, whether it's an addition symbol, subtraction symbol, division symbol, or multiplication symbol. Now that we remember all the parts of an equation, let's go ahead and work on an example to help us figure out two-step equations. Here's our first example. To solve two-step problems, we want to isolate the variable by using inverse or opposite operations to get rid of our coefficients and get rid of our constants. Whenever we're working to solve for two-step equations, the first thing that I want to do is I'm going to draw a line going straight down that equal sign to know that I want both sides to be equal. My next step is I want to use addition or subtraction to remove our constant, that number that's all by itself. So in this example, 2x plus 15 equals 35, my constant is a plus 15. I want to get rid of this plus 15. To get rid of it, I'm going to do the opposite or the inverse operation. So the opposite of a plus 15 would be a minus 15. So 15 minus 15 is going to equal 0. So what I'm left with on this side is just going to be 2x all by itself, because 2x plus 0 is just going to be a 2x. So I'm going to bring down an arrow to say that I'm left with just 2x left over. But remember, I drew that line to let me know that both sides are equal, because whatever I do to one side, I have to do to the other. We subtracted 15 on this side, so over here I'm going to subtract 15. So now I know that 2x is equal to, well, 35 minus 15, 5 minus 5 is 0, and 3 minus 1 is 2. So now 2x equals 20. But I'm not done, because our goal is to isolate that variable and get it all by itself. So now my next step is to use multiplication or division to remove the coefficient, the number in front of x. So it is 2x equals 20. So I want to get rid of this 2 in front of my x. So that's saying 2 times x. So the opposite of multiplying would be dividing. So I'm going to divide by 2. So 2 divided by 2 is just 1. So that means I'm going to be left with just 1x. So I'm going to bring down my x. 1x is equal to, well, remember, I'm drawing this line to let me know that both sides are equal. So whatever I did to one side, I got to do to the other. 2 divided by 2. So on this side, I'm going to do 20 divided by 2. So x is equal to 20 divided by 2, and 20 divided by 2 is just going to be 10. So the answer we get when we isolate the x all by itself is x equals 10. Alright, so here's our second example. The first thing I'm going to do when I'm working on these is I'm going to draw a line going straight down that equal sign to help me remember that both sides are going to be equal, and whatever I do to one side, I have to do to the other. The next step is I want to either add or subtract to remove our constants. In this example, our constant and our coefficient are set up a little bit different, because I have negative 25 plus 4x equals 73. In most cases, I'll have the 4x being the first thing that I see, then I'm adding or subtracting a constant. In this case, my numbers are switched around, but we can work through it and solve this problem. So the constant in this problem is not the 4x, The constant in this problem is the negative 25. So the first thing I want to get rid of is that constant, negative 25. Now to get rid of a constant, I'm going to do the opposite or the inverse of what it is. So this is a negative 25. So the opposite of a negative 25 is a positive 25. So I'm going to be adding 25. So getting rid of a constant, I'm either adding or subtracting. So to get rid of the negative 25, we're adding 25. So a negative 25 plus a positive 25, that's going to equal 0. That means I'm left with a positive 4x all by itself. So I'm just going to bring that down. So now I have 4x is equal to, well, whatever I do to one side, I'm going to have to do to the other. So 73 plus 25. 73 plus 25 equals 3 plus 5 is 8. 7 plus 2 is 9. So now I have 4x equals 98. Now I'm not done. I have to get rid of that coefficient in front of the x. So the way to get rid of a coefficient is I'm going to use multiplication or division to remove it. In this case, we have 4 times x. So I want to get rid of this 4, so the opposite of multiplying is going to be dividing. So I have 4x divided by 4. So that 4 divided by 4 is just going to equal 1. So now I just have 1x left over is equal to, now remember, whatever I do to one side, I got to do to the other. So 98, and I'm dividing that by 4. In this problem, I'm going to end up getting a decimal because 98 divided by 4 is not going to give me a perfect number. So I can either type that into a calculator or I can do that long division to help me figure it out. So go ahead and look at my example. So I went ahead and worked out that long division. I got 2 groups of 4 in 9, which is 8. So that means I had 1 left over. I bring down that 8. In 18, I have 4 groups of 4, which is 16. So that leaves me with 2. Now I'm going to go to my decimal place. So I'm getting a 0 from behind that decimal. So I have 20. And at 20, I can get 5 groups of 4, which is exactly 20. So I can stop there. So when I divide 98 divided by 4, I get 24.5. So in this example, for example number 2, x is equal to 24.5. So we've gone ahead and isolated that variable, got it all by itself, and we found our solution for example number 2. So here is our third example. We have negative 6x minus 20 equals 70. My first step is I like to draw a line straight down that equal sign to help me remember that both sides are gonna be equal. The next step is I use addition or subtraction to remove the constant. I'm getting rid of that number that's being added or subtracted. In this case, I have minus 20, so I'm gonna get rid of this number first. The opposite of a minus 20 would be a positive 20, so I'm gonna be adding 20, because negative 20 plus a positive 20 is going to equal 0, so that's how I remove the constant. And all I'm left with is the negative 6x. So I'm going to go ahead and bring that down. But remember, whatever I do to one side, I got to do the other to keep it equal. So I added 20 on this side, so over here on this side, I'm going to add 20 as well. So 70 plus 20 is equal to 90. So negative 6x equals 90. Now my next step is I use multiplication or division to remove that coefficient. So in front of the x I have a negative 6. So this is negative 6 times x. I'm getting rid of this negative 6. So the opposite of multiplying is going to be dividing. I'm going to divide by the negative 6. Remember, since this was a negative 6, I'm going to divide it by a negative 6 because I want to get rid of everything right here and have x all by itself. That includes getting rid of that negative. So a negative 6 divided by a negative 6 just means I'm going to be left with 1x. So I'm going to write an x all by itself because that's the only thing that I have left over. X is equal to, well, whatever I do to one side, I have to do to the other. So now I have 90, and I'm dividing that by the negative 6 on this side. 90 divided by a negative 6. So I have a positive number divided by a negative number. Since there's only one negative, I know my answer is going to be a negative. So now I'm just going to worry about 90 divided by 6. So when I have 90, how many groups of 6 are in 9? There's one group of 6, so that's one time. I'm going to be left over with 30. So if I have 30, how many groups of 6 are in 30? There's 5 groups. The solution to problem number 3 is x equals negative 15. So here's our last example, example number 4. Negative 10 equals negative 5x plus 30. First thing I want to do is I want to draw that line going straight down that equal sign to make sure both sides are equal, because whatever I do to one side, I gotta do to the other. Now in this example, x is on the other side. It's on the right side of our equation. So that's not going to change anything I'm doing. I'm just going to be working on the right side now instead of usually that we work on the left side. It doesn't matter, because whenever I'm working on these problem solving for equations, I'm trying to isolate the variable by using those inverse operations. So I want to get this x all by itself. So I'm doing all my work working on the side of whatever the x is on. Now my first step was drawing the line. My next step now is to get rid of the constant. So this is saying plus 30. Right here is my constant. So the opposite of a plus 30 is going to be minus 30. So I'm subtracting 30, and a positive 30 minus 30 is going to equal 0. So those are going to go away, and I'm left with just negative 5x. Bring that down. Negative 5x is equal to, remember, whatever I do to one side, I gotta do to the other. Even if I'm going from the right side to the left side, whatever I do to one side, I have to do to the other. So I subtracted 30 over here, so on this side, I'm gonna subtract 30 as well. So now I have a negative 10 minus 30. So the way I like to think about this, whenever I'm working with negatives and subtraction, I owe somebody $10. Now I owe them $30 more. So in total, how much do I owe them? I owe them $40. So that's a negative 40. Now negative 40 equals negative 5x. My next step is I want to get rid of that coefficient in front of my variable x. So I want to get rid of the negative 5, and negative 5 times x, the opposite or inverse operation that I'm going to use to remove it is division. So I'm going to divide by negative 5. So a negative 5 divided by a negative 5 will just equal 1. So I'm left with just 1x, x all by itself, equals, well remember, whatever I do to one side, I have to do to the other side. So negative 40 divided by negative 5. Negative 40 divided by negative 5. They're both negatives, so that's going to mean they're going to be a positive answer. So now I'm just going to think about 40 divided by 5. 40 divided by 5 is equal to 8. And it's going to be a positive 8 because a negative divided by a negative equals a positive. So the solution to our fourth example is x equals 8, or the way that we wrote it, 8 is equal to x. Alright guys, so if you found this video helpful, make sure to hit like and subscribe down below. And until next time, bye!